All right, Algebra 1. Welcome back, guys. We are officially in the last section of Chapter 9. Okay, so listen, you guys have come a long way. Chapter 9 is a big chapter, not only having 9 sections, being by far on the long side when it comes to chapters, but also there are a lot of big concepts that you guys have gotten through in this chapter. So for starters, tip of the cap to you guys. Listen, you made it through another chapter, but let's also make sure that we understand what that means is that we built a lot going through this entire chapter. So that means that you guys have to keep putting in that extra effort, okay? Making sure that when you watch these videos, you are taking diligent notes. That's really important. That's part of your foundation. That's part of the key to success, making sure that you guys ask questions when they come up. All right, write them down, make note of it, put a little something next to the notes on your papers. That way when you come to class, it reminds you, whatever it takes, okay, to put that effort in that will equal success in the long run. Okay, so here we go. Last section, we are factoring polynomials as we've been doing, and completely. So you're going to see that completely in this section means you may actually have a polynomial bigger than 3 terms. All right, so we've been working with trinomials, meaning 3 terms. You may now up it to like a quadnomial, if you will, that we're dealing with 4 terms in quite a few of these problems, okay? But step 1 right here, step 1, no matter what the polynomial looks like, you may have 2 terms, 3 terms, 4 terms. You always, step 1, look for common terms that can be taken out of each part. All right, each part being a monomial. All right, look for something that would be a common number or a common variable that can be factored out. And you're going to see us do that a few times in these example problems. So that's step 1. Okay. Then as we get into something that's going to look new, polynomials that have 4 terms, we're going to use this method that's called factor by grouping. All right, factor by grouping, meaning what you are going to do is you're going to have 4 terms, but you're going to group them in groups of 2 terms, okay? So in other words, take 4 terms and then split it up into here's a binomial, 2 terms. Here's another binomial, 2 terms, all right? And you're going to see us work through a few of those. So that's this grouping mentality. That's the group, all right? 2 binomial pairs, all right? Remember, a binomial is 2 terms. And then what you're going to do is separately, key part, you will factor each binomial pair. All right. And again, I've highlighted the key parts that I've written out here for you. All right. And then at times I've actually had students wonder, well, like, when do I know I'm done, like factoring a problem? Or they try to even go too far, maybe, or usually what the case is they actually don't go far enough when they're factoring. But you stop when there is nothing left to factor out, in terms of there's no more common terms, you can't take anything else out, and you've already simplified it down, and you're just left with unfactorable polynomials that are going to be multiplied together. Okay, and you'll see what those look like. Nothing left in common, and you're going to have the binomial pairs in parentheses right next to each other. Okay, so let's take a look at an example problem already worked out for us here. Again, brand new. We're looking at 4 terms, okay? So x to the 3rd power plus 3x squared plus x plus 3. There's 4 terms there. And what they are going to do, here is our grouping mentality. You see the first 2 terms right here are what they put in parentheses right here. Okay, so they are grouping, again, the first 2 terms together right there. Then you have this plus sign is this plus sign right here. And you're looking at x plus 3, That is right here, x plus 3. They group that together. Then we go one group at a time. For starters, x plus 3 can't go anywhere. So leave the x plus 3, same thing, x plus 3. But you'll notice that I have 3 x's here, 2 x's here. So that means I have 2 x's in common for both of those terms. That's why they factor out an x squared. They take it out, and then let's rewrite that set of parentheses after we have factored it out. This used to have 3. I took 2 out. I have 1 left over. This had 2. I took it all out right here, so it's totally gone. I just have the 3 left over. Now, you'll notice in this chapter, if there's a way to have a checkpoint, like you know you did it right, this is one of those sections that also has a checkpoint. So how do I know I did this right? Because these sets of parentheses will be identical. All right, and in this case, x plus 3, x plus 3, identical, it was done correctly. Then these are actually the same term, right? So you only really have one of them. That's why you'll notice it looks like, okay, I had 2, but then only 1 drops down. They are the same term, in fact. So that's how you know you've done it right, when the same term pops up. And that's why only one of these is dropping down, because that's really all you have. Then you may be wondering, how did I get this right here, the x squared plus 1? It's because what you factored out gets put together in its own set of parentheses. You'll notice I didn't factor anything out. So what's always there but never written? The good old magic number 1. Okay, so put these together, and that is what is written on the out in its own parentheses right there. Okay, all right. So we'll take a look at one more example. In this case, we have some signs that are a little different. We got a positive term, but then there's a negative and a positive and a negative. So the signs are different. And we may need to rearrange the terms if they don't actually group well. And what do I mean by group well? I mean, you can rearrange the terms so that you can factor more out. All right, that is very, very possible. That's okay to do. So let's take a look at how they rearrange this. That negative 3x squared, they move it up because that x to the third power, they share a lot of x's together. So we're able to move this entire term because it was in the back, but we move it to now be the second term because we're sharing a lot of x's, and we can factor those out. And then these guys share the number 2 together, so that's good. Let's leave them with the 2 to take out. So that's what we factor out, is a 2. And these guys both share an x to the power of 2, so we factor that out. And how do we know we did it right? Because what's left over in parentheses matches perfectly. It's identical. And then whatever you factor out right here, that gets put in its own set of parentheses. All right, so let's do some example problems. Let's see how these work. All right, so you get a little bit more practice. So the way I see this written, everything's all good as is. X plus 3, I can't change that. But these guys, x squared and x to the power of 3, they already share 2 x's. So let's go ahead and group these 2 together and group these 2 together, leave it as is. But in this case, with our first group, they have the x squared in common. 3 of them here, 2 of them here, they can both give up 2. So take out the x squared and never forget what's left over. I have 1x left over plus 3 plus, and I'm going to put that 1, that's the unwritten 1, x plus 3. I've done it right because the x plus 3's match up perfectly. And then don't forget in parentheses, we're going to have what we factored out create its own set. X squared plus 1, x plus 3. And that right there is as far as we can go. So let's determine how I know this is done. Because x and 3 don't share anything else. X squared and 1 don't share anything else. So I can't factor anything else out. Leave it. All good. Done. Okay, let's take a look at this one. It's nice that we're looking at all plus signs. Okay, now do I want to rearrange it, or am I good as it is? And if you look closely, I would recommend leaving it as is. You'll notice that these guys, if I put them together, they share a y. That seems good. If I put these guys together, they share an x. So let's leave it and put our set of parentheses around the first two as they are written, and then around the second two as they are written, and look at them individually. All right, just looking at this, they each share an x. So I can factor one of those x's out, and then never forget in parentheses what is left over. Well, if I took an x away, that had 2, that means there's 1 left over. This one only had 1, so that means the only thing left over is just that plus 2. Now, let's see what these guys share. They both share a variable y, so we're going to factor a y out. And then in parentheses, only an x is left over, and the 2 is left over. And again, my checkpoint is that they are the same, x plus 2, x plus 2. So now, what we factored out gets put into its own set of parentheses, x plus y. And the leftover x plus 2 just drops straight into our answer. And there we go right there. Okay, so this is our intro into factor by grouping. All right, don't forget, anything goes a little bit too fast, pause it, rewind it, go back. All right, this one we have to solve. So we will be factoring it, but then whatever we're factored at the end, we have to make that equal to 0, just like we have right here. And we could get multiple answers, right? All right, let's think back. What did I say at the beginning is always your step 1, no matter what the problem looks like? Look to see if you can factor something out of everything. And in this case, you can. Look at this. There's an x to the third, so I have 3 x's. Right here, I have 2 x's. Right here, I have 1 x. I can factor an x out of all of the terms. So let's do that. Take an x out and then rewrite this. So this is now what we're looking at. And this is a regular looking trinomial. Okay, a regular looking trinomial. So let's see if this is actually a special trinomial, because I want to try and get you used to looking at these trinomials and see if you can figure out something special about it. And if you remember back in the last section, this is going to fit those special parameters because x squared is a perfect square. 16 is also a perfect square. And we're looking at a plus sign right there in our second term. Those were the 3 parameters that made a perfect square trinomial. And guys, this is going to best be understood through repetition, just more practice, all right? More practice. I'm not saying that everybody's going to see that yet, but the more you do, the better you're going to get. All right, so don't forget that x. It's still there. And with a perfect square trinomial, they break down, and it is identical binomials. All right, x minus 4, there's another x minus 4. How do I know this works? What is negative 4 times negative 4? Positive 16. What is negative 4 plus another negative 4? It's negative 8. That works out perfectly, all right? So off to the side, negative 4 times negative 4 equals a positive 16. That's what we want. And -4 plus another -4 equals a -8. That's also what we're looking for. But we're not done. It says solve. So we need to actually set each of these up equal to 0. Well, this one works out great. X equals 0. That one's done. You'll notice that these are the identical part. These are the same. X minus 4 equals 0. So x equals 4. And since we have the same thing twice, we don't have to write it twice. You just have to say x equals 0 and x equals 4. All right, so that's how we solve that one. Okay, now we're looking at a binomial, only 2 terms, but always step 1. Look at what could be factored out. Look at this, x cubed minus 25x. What do they both share? What do they have in common? Each of them have an x. That one has 3 x's. That one only has 1 x. So the biggest thing I could take out of both is just 1 x. Let's do that. There's an x. Rewrite it. X squared minus 25. Is there anything special about it? Take a look at it. Is there anything you may notice? This is a perfect square binomial. All right, and let's review that. How do I know? Because x squared is a perfect square. 25 is a perfect square. And the final piece for a binomial, it has to have subtraction. All 3 parts are there. So that means, don't forget the x on the outside, but this will factor x plus 5, x minus 5. Now, how do I remember that? Because you'll notice there's no middle term, right? There's only 2 terms. We go from x squared to just the constant value. So something must happen to that middle term. When you're checking, how does it drop out? You always could remember the double smiley face is the best way to check. What is 5 times x? 5x. What is x times -5? -5x. Well, that's 5x minus 5x. That's 0. That means it drops out. So we won't have a middle term. We did do it correct. Okay? So all of this still works, but we got to solve it. All right? There is that one more piece where now we're going to have to solve all 3 parts. So this first one, nice and easy, x equals 0. That's great. This one right here, x plus 5 equals 0. X equals a -5. Okay, and then the last one right here, x minus 5 equals 0. X equals 5. Okay, we actually have 3 answers for this problem. X is 0, x is 5, x is -5. That's solving this entire problem. All right, here we go. I believe this is our last example problem here. Yes, it is. Okay, so look at this. It's a trinomial, but they share something. Look at what they share. What is it? They all share 1x. There's an x. There's 2 x's. There's 3 x's. How much do they all share, though? Just the 1x. So let's take the x out and rewrite what we have after we take that x away from all 3 terms. Okay, so this trinomial is not a perfect square. We can figure that out pretty quickly here. X squared, good. Okay, that's a perfect square. That works. But 12 is not a perfect square. Okay, so we know that we're not dealing with a perfect square trinomial. This is just factoring a trinomial, meaning that we have to find the 2 numbers. There's x, there's x. Don't forget the signs. Okay, when your signs go minus, then plus, in parentheses, it will go minus and minus. All right, so we're looking for factors of 12. You have 2 and 6. You also have 3 and 4. And I always recommend starting with the factors that are closest together. And in this case, 3 and 4 are those, and 3 and 4 are the magic perfect combo. Because what is 3 plus 4? 7. And what am I trying to create? 7. So that is the magic combo, 3 and 4. Okay, there we go, but we're not done because it says solve. So we have all three of these. Set them equal to 0. And solve each of them individually. Okay, so we again are getting 3 answers for this problem. X equals 0, X equals 3, and X equals 4. All right, guys, there we go. That was section 9, last section of the whole chapter. All right, we're kind of trying to bring everything together. All right, let's zoom out a little bit here. So you can see everything, examples 3, 4, and 5, right there on the page. Okay, worked out. And then right there, examples 1 and 2 worked out. So that kind of lays it out there for you. So you can see everything, again, 1 and 2, and then 3, 4, and 5. Again, if you want to pause, screenshot, helping you take those notes. All right, guys, you got this. Keep working hard. Okay, bring your questions to class. I'll see you guys in the next one.